So first of all, you're all very welcome to Clyde Road, and for everybody here and joining us on the webcast to the Energy Environment Division's third monthly lecture of the season. I suppose if I can just ask you to check your phones, fire exit. Check my phone. And then there's an attendance list going around, but sorry, if you've already signed in at the door, that's fine, no need to sign off twice. I suppose for those of you who are attending for the first time or dialing in for the first time, this is part of the Energy Environment Group's 7 monthly lectures, which run from October into May, and typically we deal with topics dealing with energy and the environmental impacts of energy. Tonight's presentation is titled A Green Gas Future. So Ireland's gas grid and its role in decarbonisation, supply security and cost competitiveness, and it'll be presented by Dr. Rory Monaghan from NUI. So Rory's a lecturer of energy systems engineering and mechanical engineering at NUI Galway, position he's held since 2012. Rory obtained his master and PhD degrees in mechanical engineering from the Massachusetts Institute of Technology. Rory's research interests encompass multiple aspects of thermal energy, specifically combustion and gasification of renewable fuels, low emissions, combined cooling, heat and power systems, and is a member of the Gas Innovations Group. So with that, Rory, I'll hand over to yourself. And we might have a Q&A then at the end of the lecture.
Great. Thanks very much, John. Well, thank you all for coming out this evening. As John said, I'm Rory Monaghan. I'll just briefly go through some of the affiliations here and maybe give a quick explainer of what they are. So I'm a lecturer of mechanical and energy systems engineering at NUI Galway, and I am also a funded investigator for the Centre for Marine and Renewable Energy in Ireland, which is MARI. It's an SFI and industry funded research centre that's been in operation for the last number of years. I'm also I'm a member of the Gas Innovation Group, which is the primary topic that I'll be talking to you about, and I'll explain what the Gas Innovation Group is and give examples of some of the projects that we've helped support over the last couple of years. So I'll start by just giving maybe an overview of natural gas in both a world context and in the Irish energy system, just to kind of give everyone a bit of a grounding in it. I'll explain what the Gas Innovation Group does, and then I'll try and spend a good portion of my time giving some examples of the funding the projects that have been funded by the Innovation Fund, both on the research and demonstration side, and maybe talk about some ideas for the gas grid in the future. So on a very basic level, this is the world's fuel mix essentially. So looking at the primary energy supply. So we don't see electricity in this. What we see is the fuel that goes towards running the economy from the early 70s to recent times. And I've just highlighted the light blue here, which is the role of natural gas. So it's a little bit over 1/5 of the energy used globally is natural gas, and it's projected to increase for a few reasons, which I'll go into. This is another maybe more complex but very kind of data-rich way of looking at the energy system. This is a Sankey diagram that's been produced by the International Energy Agency, which is the energy research division of the OECD, and this shows on the left side here the primary fuels that go in towards the world's energy system, and what those fuels are used for on the right hand side. And it gives a really nice way of visualizing what fuels go where. So one sort of broad brushstroke that we can say from looking at this is that a large portion of the world's coal goes towards power generation. Okay, so if we look at coal here, we see this is all the world's power plants, and this is what that power gets used for. So coal is the number one power generation fuel. Another broad brushstroke is that most of the world's oil, or the major portion of the world's oil, goes towards transportation. So it's a nice way of visualizing. Where does natural gas fit into this? Well, natural gas is the blue line here in the middle. This is not saying that planet Earth imports natural gas. Obviously, that's not the case. This is just looking at the breakdown between gas that's produced and consumed within one country, comparing it to gas that is internationally traded. But An interesting feature that we notice about gas is that gas is used across a large range of sectors in a way that other large-scale fuels are not used. So its main use is in power generation, but it is also used across the board. Now maybe the transportation one there is quite small, but I'd like to maybe talk about ways that might change in the future. So kind of the overall message that I want to get across with this slide is that gas is used across a number of sectors of the economy. And something else maybe that I'd like to just emphasize, and it's something that those of us who work on maybe the thermal side of energy like to say a lot, is that electricity is a part of the energy mix, but it is not the major part of the energy mix. Electricity makes up maybe about 20% of overall energy use. But if we were to say very broad brushstrokes, about 40% goes towards direct use of fuels for heating, and another 40% goes on transportation. So I'd like to sort of differentiate between electrical energy and total energy, and that'll sort of come through in my presentation later on. So there has been an increasing use of gas in recent years for a number of reasons. So it's increasingly being seen as a low carbon alternative towards with respect to coal. Combined cycle power plants, CCGTs, are relatively cheap to build. They're still a large investment, but more of the cost of electricity of a CCGT comes from the fuel than from the building of it. So you can get them built quite reasonably cheaply. There's been an increase in the diversity of supply of natural gas, which has brought the cost down significantly in the last number of years. And the two main drivers that are talked about worldwide are the exploitation of shale gas and the increasing use of LNG. In Europe, we haven't really embraced shale gas to a large extent, but there is a large increase in the amount of LNG being, or the portion of gas traded that is made up of LNG. And I guess on the technical side, on the engineering side, there is a good complement. There's a good complement between natural gas and wind. Gas-based power plants can be operated in such ways that they can pick up capacity that may be shed by intermittent renewables, and so that's gas and renewables are seen as being good partners in an electricity system. In Ireland, this is how our natural gas system looks in Ireland. I'll go through some usage statistics in a minute, but Ireland has got on the supply side, there are at the moment really two big supplies of natural gas in Ireland. One is up here in Scotland. This is Moffat. So this is showing the Irish natural gas network, and this is owned and operated by Gas Networks Ireland. So the natural gas network of Ireland actually begins up here in Scotland. This is part of the Irish system. Goes under the Irish Sea in these interconnectors and feeds into the system. Operates mostly in there's this main ring here, Dublin, Galway, Limerick, Cork, and other branches off that ring. The other major supply on the Irish gas network is the Corrib field, which came on last year, and is projected over this year and next year to meet about 55% of demand, and it's currently getting up to that. It's at about 30%. Kinsale production at Kinsale has decreased significantly. Kinsale used to supply the majority of the gas used in the Irish system, and it has been used for gas storage over the last number of years, but its use is being wound down now. How gas is transmitted from the supply side to the demand side is by a transmission and distribution network. Very similar terminology to what's used on the electricity network, except instead of voltages, we talk about pressures. So there's 2,500 kilometers of high pressure system and about 11,000 kilometers of low pressure systems. And then once we get into built up areas, that pressure is reduced down to about to close to atmospheric pressure. Another interesting feature which I'll talk about, it'll be relevant when I talk about some of the projects that are being funded by the Gas Innovation Group, is the presence of about 50 AGIs. And these are above ground installations, and these are access points into the natural gas network. These will be particularly of interest for those looking to feed into the network when we start talking about renewable supplies of natural gas. On the demand side, the world figures were about 21% of primary energy coming from natural gas. In Ireland, we're a little bit more fond of natural gas, it's about 27%. 640,000 homes, 25,000 businesses, and it is the major contributor to power generation in Ireland at a number of, now this is the installed capacity of natural gas based generation. This is not operating all the time. There are some open cycle plants which do not have large run hours, but on an energy basis, 43% of the fuel going into power generation is natural gas. This is how gas fits in the overall Irish energy system. There's that 27% of all our resources that come in. So only oil is a bigger contributor. And the Sankey diagram for Ireland, showing gas's role in being the major power generation fuel. And in Ireland, we don't currently use any natural gas for transportation, but we're using natural gas across other areas. Sorry, we do use natural gas for transportation in very, very small quantities, but it's not reflected here in this figure. So those of you who follow the news might have seen about 3 weeks ago that the Gas Networks Ireland (GNI) announced plans for a large-scale compressed natural gas filling station network. So I just thought that I'd mention this now, and it will maybe give context to some of the things that I'll be talking about later. So the overall target is that 20,000 heavy goods vehicles and 12,000 buses will be converted to compressed natural gas. Now, why would people want to convert to a gas fuel from a liquid fuel? Well, there are a number of reasons. There's price volatility is more significant for oil products than it is for natural gas. There's been a significant decoupling in recent years of the cost of natural gas from the cost of oil, which were always traditionally linked. But there are less emissions. There's lower emissions, so maybe not as much of a drop in CO2 as some people may expect, but there are significantly less atmospheric pollutants, so the pollutants that do harm to human health associated with natural gas compared to diesel. So the NOx is these smog forming and respiratory attacking pollutants, and PM is particulate emissions. So you can almost eliminate particulate emissions by using natural gas. So in order to address a number of challenges that were facing the natural gas network, GNI decided to establish an organisation called the the CER set up an organisation called the Gas Innovation Group, which is chaired by Gas Networks Ireland. Some of the challenges that were facing the natural gas suppliers was that even though a large amount of natural gas is being used to provide fuel for the electricity system, an increase in renewables has actually caused a slight decrease in the demand for natural gas in recent years. Gas Networks Ireland, being in the business of transmitting gas, we're interested in finding ways to address that. There's the emissions reduction issue that we don't really use natural gas for transportation in Ireland now, and we can see that there are major environmental benefits of shifting from some of the dirtier fossil fuels to natural gas, which would be the cleanest fossil fuel. And it also matches well with renewable energy on two fronts. It's a good complement to existing renewable electricity sources, but natural gas can also be, the natural gas grid can also be a delivery system for renewable energy through uses of technologies such as anaerobic digestion, where you can produce methane from a renewable source and inject it directly into the grid. This would be a way of of making progress towards some of our renewable energy targets, which I'll show later on. So the Gas Innovation Group was given an initial innovation fund of €8 million to go until 2017, and its purpose of the Innovation Group is to advise Gas Networks Ireland on where it should invest in research and demonstration projects, and that's what I'll be talking about for the bulk of this presentation. So this is just some of the text from the reasoning behind the CER's decision to establish, and within the decision-making process of the Gas Innovation Group are these 5 pillars, really, that establish whether a potential project is going to be advised for funding, or is going to be recommended for funding or not. So, does it increase the gas grid utilization? Does it address reliability and security supply issues of gas? Does it provide benefits to gas customers in terms of costs, in terms of stability of supply? Does it help in the transition towards low emissions that the country as a whole is having to get to? And does it do anything to enhance energy savings? So just some final information on what the Gas Innovation Group is. It's comprised of members from the policy making side. The industry representation is from Gas Networks Ireland, and then on the academic side we have Cork Institute of Technology, University College Cork, myself from NUI Galway, and we've got Dublin City University as well involved. So we try and get this cross-sectoral perspectives of what is of value to the natural gas system. Right, so I'm going to break down the presentation of some of the research projects into two categories. I'm going to talk about research, which I'll sort of focus more on maybe on the academic research side, and then demonstration, which is the actual implementation of these of some of these new gas-based ideas. So we are on the research side. I'm going to look at basically some future ideas of where the fuel that's transmitted by the natural gas network can come from. So these are going to be renewable sources of natural gas renewable sources of methane, as opposed to the fossil sources that we currently use. So I'll be talking about anaerobic digestion and gasification. I'll give very brief overviews of what these technologies are, but they are complementary technologies where we can use waste or available biomass materials to produce methane that can be injected into the gas grid. There's also some research, very early stage research, that's being funded on hydrogen-based technologies. This is mostly in the desk study side, so that's a quite an early stage, and also some research which I'm not going to be going into much detail in this study, but looking at the socioeconomic drivers of gas, what drives people, businesses to switch to natural gas, and how can that switch be encouraged more. On the demonstration side, the two main areas of demonstrations that are funded by the Gas Innovation Group is on anaerobic digestion plants. Anaerobic digestion is a well-established technology now, and but it's about getting installations in the ground at the moment. So the group has helped fund some demonstration projects, and the group is also helping to fund pilot demonstrations of conversion of heavy vehicles to CNG, and helping to put the fueling infrastructure in place for that. So, focusing on some of the research, some of the more academically focused research for now, just by means of an explanation. Gas Networks Ireland has joined 6 European gas grid operators in committing to have a 100% carbon neutral gas grid by 2050. So it's a very ambitious target that's that's just over 30 years away, and that's moving from a fully fossil fuel based gas system to one whose carbon emissions are completely offset. So this is some of the intermediate targets that have been established by Gas Networks Ireland. Producing RNG stands for renewable natural gas. So what percentage of the gas in the network will be renewable natural gas up to the final intermediate target year that we have for now is 2014. So 12% of the gas by 2014. And the major demand for this is coming from multinationals. There's been a large movement in recent years that shareholders are demanding environmental accountability for the companies that they invest in. And you know, a case in point, the one that's talked about most certainly in the west of Ireland is Apple. Apple announced that they were, a little bit over a year ago, announced that they were going to build a large, an enormous data center just outside Galway at Athenry here, which is on the gas grid. And one of the conditions they had for building that was that they could be guaranteed 100% renewable energy for that site. Now, when you go through the numbers, the order of magnitude of annual energy demand that site has is comparable to Galway City's energy demand. So it's a very, very significant amount of energy being used at that site. So getting Galway City's worth of renewable energy delivered to Athenry is a major issue. So it's data centers. They've got heating, cooling, and power requirements. So Gas Networks Ireland are very much interested in trying to get organisations like Apple, types of sites like data centres on board and pushing the demand for renewable gas. So there are other examples that I could go into, but just certainly for the west of Ireland, Athenry is the focus. Now, there's other reasons why this site is being held up. It's not only the renewables that are holding that development up, but that's a different story, and that's not just an engineering issue. In terms of why people would use the gas grid as a delivery system for renewable energy, I just like to present some rough numbers, and these have been produced by Jerry Murphy in UCC in a piece he wrote for the Engineers Journal last year. That if we can break down very, very roughly energy use into electricity, heating, and transport, and you see this 20-40-40 breakdown roughly. Then, in order to reach our European 2020 targets, what's known as the 20-20-20 targets, the European Union as a whole has to have 20% of its energy coming from renewable resources by 2020. It has to reduce carbon emissions by 20%, and it has to increase energy efficiency above a baseline by 20%. So that's called the 20-20-20. Ireland's specific targets within that European target is 16% renewable energy by 2020. And this is the breakdown that Ireland has chosen to pursue. So 40% renewables in the electricity sector, and then 12 and 10 in the transport sector. And this is how they play out in the overall energy mix then. So we've got significant challenges in meeting these thermal and transportation energy challenges that say, for example, unless we have a large-scale electrification of transportation, we're not necessarily going to see the benefit of increased wind energy installation outside the electricity network. If what I mean is, unless we have a way of using electricity in more sectors, we're not going to be able to use that wind energy for anything other than electricity. So we see the gas grid as being a potential way to do that. Now, this is very kind of busy, but I'll try and explain this a little bit. This has been produced by the International Energy Agency, and it's been produced for the Netherlands, who are one of the leaders in the use of renewable natural gas or green gas. This is showing starting up here in now, basically. We're looking at what technologies and what resources can be used practically to provide renewable methane onto the gas grid. So anaerobic digestion processes that use grass or that use manures are well-established technologies, and they are with the right incentives can start supplying gas to the grid now, and in many cases they are. Germany and Denmark have got large portions of anaerobic digestion on their grids. Going then, there's sewage sludge is maybe a more sort of topic that's currently under investigation. It is being done at some wastewater treatment plants, that energy is being recovered, but it's not being injected to the natural gas network. It's being used to generate power on site. Going then into the future, into these more emerging technologies, we're looking at using harder to break down feedstocks. So these would be harder, woodier, more contaminated perhaps feedstocks, and these would not be suitable so much for anaerobic digestion, which is a biological process. These would be maybe more suitable to something like gasification, which is a process that's not a million miles away from combustion in terms of the conditions that are encountered. Something has happened here. Ooh, a scan. Yes, let's stop the scan. Yeah, democracy. Okay. And then, yeah, that seemed to work fine. And then there are some other feedstocks that are maybe further into the future technologies that are not ready to go yet, but that are certainly worth investigating at a research level. That would be using seaweeds and other algae, and hydrogen-based technologies. All of these. So we can now into the far future. We can start to imagine this system where you can have the natural gas grid and the electricity grid combined through the use of hydrogen, and using that hydrogen to produce renewable methane. I've got a little schematic of what such a system might look like later on. But so anaerobic digestion is a more well-developed technology for biomethane production than gasification. So let's have a look at what some of these technologies are. So essentially, anaerobic digestion is taking a wet biomaterial, a substrate, and is adding what I'm going to call bugs to it, and is left in an oxygen-deficient environment. And what happens is we have a breakdown of that biological material into a series of gases. One of the key steps in this is the conversion of volatile fatty acids into methane. And that methane comes out as a mixture of 50-50 methane, carbon dioxide, with a little bit of cleaning up. That can be injected into the gas grid, or that can be maybe used as a vehicle fuel. The other thing that comes out of it is digestate, a solid material digestate, which in many cases, depending on the feedstock you originally put in, can be used for fertilizer, or can be used for soil improvement. So it's a way of maybe closing some of the loops within the agricultural sector. This is an example of a grass-based anaerobic digestion fuel production system in Austria. This is not funded by the Gas Innovation Group, but it's an indication of what is possible with anaerobic digestion. We have the harvesting, we have the digestion, storage, the cleaning and storage here, and then eventually this is used to run some of the local transportation systems. So it's a nice sort of closed loop. What the Gas Innovation Group has been funding has been performing resource studies in Ireland. So this is work that's been performed within MARI, specifically at UCC, where the spatially resolved resource for a large number of feedstocks that are suitable for anaerobic digestion can be studied. So, in this, the darker the color, the more the resource available. So you can kind of see a summary down here that the theoretical, I'm just going to take the example of cattle slurry, which is a well-distributed resource, but the theoretical quantity of gas that could be generated from cattle slurry is about 44% of what Gas Networks Ireland 2024 goal is. Now, you're never going to get all of that slurry because a lot of it is on the field. It's not practical to get. Some of it's going to be too far from the gas grid. But this gives a first indication of how much of that resource there is. And this work was funded to look at a number of other feedstocks as well, which you can see there. And some further studies that were done here. Another interesting one here is looking at the household separated organic waste, which is one that I'll look at in a little bit more detail. This one is interesting because where you have houses, you have organic waste. Where you have houses, you have energy demand. So there's potentially a good link between those two. And this is a graph that was produced by that work, that UCC work. And I just want to there's a lot of information here. I just want to look at two things. This blue line here is net present value. So what we have on the blue line is showing net present value for a range of different proposed anaerobic digestion sites that would produce green gas. And these different sites would use a range of different feedstocks, which are indicated by these colored bars here. So the first sites on the left are the ones with the highest net present value, the most potentially profitable sites. They're all operated using household waste. Then as we get into the lower net present value ones, this is looking at more slurries and grasses to be used over here. But the first ones are sites that use organic waste, and they've got a high net present value according to the study. And most of them are based in the greater Dublin region, which obviously makes sense. There's good agricultural land in the outside Dublin and high energy demand inside Dublin. So this is where the work is at with the anaerobic digestion resource studies. Looking at different types of feedstocks. Feedstocks that would not be suitable for anaerobic digestion, which don't have the high moisture content required for anaerobic digestion, is gasification. This is work that I'm leading in Galway. We are in the process of doing a similar study for feedstocks that are related to gasification. So this is an example of a Swedish plant which, with expansions up to 2020, will be producing enough biological, so there's bio-SNG is biological synthetic natural gas. It's producing enough to run 100,000 cars for the year. So it's a significant plant. Now, Sweden is a very heavily forested country, and wood is the ideal source of fuel for a gasifier. We don't have as much wood in Ireland, so what we started doing was looking at a similar study, looking at what types of resource we have available in Ireland. And the resources we looked at were cereal straw, leftovers, looking at the outputs of digestate that would not be suitable for spreading on land, and the black bin waste, residues from forestry, from Cuilchan, from private forests, and looking as well at the use of low-value agricultural land, so what's called marginal land. Now that's a difficult definition to pin down, but you can grow energy crops such as miscanthus on low-value land without really offsetting too much agricultural activity that's going on. So when we sum all these up, we can make some comparisons to the Gas Networks Ireland 2024 targets, and we can see that that some of these do start to make significant dents into that target value. So what the current state of this research is on is now looking at where are the optimal locations for these gasification sites. A lot of the gasification resource would be, say, in areas that are not particularly near a natural gas connection. So how do we design a system that gets the raw resource to the gas grid, and how do we do that in the most efficient and most environmentally sensible way. On the demonstration side then, this is a project that's being funded at Ormond Organics, and they've got this will be when it's completed, and it's targeted for completion in at the end of 2017. This will be Ireland's first industrial scale anaerobic digestion connection to the natural gas grid, and the funding that was awarded from the Gas Innovation Group for this was on the gas purification and upgrading side. So, as I said, the biogas that comes out of an anaerobic digester is about half methane and half carbon dioxide, and that produces a calorific value which is not adequate to go on the grid. So you need to remove that carbon dioxide. You need to remove some other things like sulfurs. If you're producing your gas from slurry, there's going to be sulfur in there as well. So you need to remove all of those contaminants if you're going into the grid. You may not need to remove those contaminants if you're just using the energy on site, but if you're going into the grid, you have to do that. This is the grid connection here. This is the natural gas network, and this is the connection going to the or coming from the anaerobic digester. So the funding was awarded for the installation of this purification and upgrading site. Another project that was funded is this trailer-mounted anaerobic digester, and this is, if people have been to the ploughing championships, this is a perennial favourite at recent ploughing championships, where they can run demonstrations on the trailer of the production of gas. This is JP Prendergast, who is one of the people behind the Claremorris and Western District Energy Co-op, which is aiming to have anaerobic digestion running district heating and combined heat and power systems around Mayo. It's a very ambitious project. So the Gas Innovation Group funded this project as a demonstrator to travel the country and to really show people what's possible with anaerobic digestion and with these green gas technologies. There's a large number of energy co-ops are now setting up around the country, and this is really where local communities want to take more ownership of energy in their areas. On the transportation side, so that was looking at the feeding of gas onto the grid. Now we're looking at maybe the increased use of gas, and the big sector that has remained elusive for natural gas in Ireland and in most countries is transportation. Now there are certain countries who have really put a priority on air quality that have introduced compressed natural gas. So for example, Iran, Pakistan, Argentina, all of those countries would have about half their vehicle transportation fleets would run from compressed natural gas. And those are countries that are very susceptible to poor air quality. Particularly some of their big built-up sprawling cities would have very poor air quality. So diesel is typically not allowed in countries that are susceptible to poor air quality. So compressed natural gas is seen as an efficient heavy vehicle transport fuel. So this was this CNG truck was introduced to the Irish market now. So the Gas Innovation Group will fund the differential, basically the conversion cost from a class 6. I think it's it'll fund the differential from the lowest emission category of diesel truck to CNG. There is a cost for conversion, so the Gas Innovation Group will help in that funding. This is one of the first CNG filling stations in the country. It's based at the Gas Network's headquarters in Cork, and this is connected up to the underneath these walkways. Here is the connection to the gas network. This is the storage and the compressors here, and then this is the dispenser. And this was also funded by the Gas Innovation Group, and the idea is that these will form the backbone of this conversion to natural gas fueled transportation. There's a groundbreaking at the Clean Ireland recycling facility in County Clare. So there is they're putting in a fast fill CNG station. So there's fast fill and slow fill, much like there is with electric vehicle charging. So fast fill, you'll fill your tank in 5 or so minutes. Slow fill, 3 to 5 hours perhaps for filling up. So there'll be a fast fill one going in here in County Clare. And then there's been a demonstration project running in Cork. It's entitled IGBF, so Ireland's greenest bus fleet. Yeah, sorry, I can't see it here. Ireland's greenest bus fleet. And the idea is that this is part of the Energy Cork initiative, where they're looking at a range of different fueling options for buses within Cork, and they're looking at all options, CNG being one of them. And this is the CNG bus on the streets of Cork. So what the Gas Innovation Group helped fund was a temporary CNG filling station at the Capwell depot in Cork, and there's currently investigations ongoing to put in a fast fill permanent station at the same site that would enable a constant presence for natural gas fueled transportation in Cork. But in terms of using gas for public transportation, this is the most developed project that's ongoing in Ireland at the moment. And what all of this is building up to is this Causeway project. So Gas Networks Ireland was recently awarded funding from the European Infrastructural Network Fund to commence the first stage of this nationwide CNG network, CNG filling station network. So the initial plan is to have 14 filling stations along the key motorway routes from Dublin to the border, Dublin Limerick and Dublin Cork, this is being funded, and there's also a research element to this. The key research element to this is how does the natural gas grid respond to the increases in demand at various points along the system which may not have had demand before. So this is the first stage of the rollout of the CNG filling station project. So with that, I just want to finish with this kind of final sort of vision for what those of us that are interested in the natural gas network have for its role in the future. This is a slightly complex but very descriptive diagram of a potential future energy system, where we have renewable electricity technologies producing electricity. When these are producing electricity where there's low demand, the idea is that this could go into energy storage. They're showing, for example, here deep sea energy storage, but this could also be used to produce hydrogen. Now there is no hydrogen infrastructure right now, and there's not really a plan to have a hydrogen infrastructure. But the useful thing about having hydrogen is that it can be used to upgrade biogas. It can be used to upgrade the gas from biomass that's produced from gasification and from anaerobic digestion to produce pure methane at a very high efficiency. And this will enable a sort of an integrated electrical and heat and transport energy system, with hydrogen serving as a buffer between the two. Also coming off the gasification and the anaerobic digestion are relatively pure streams of carbon dioxide, which have to be captured in order to produce the methane in the first place. So there is a potential to have this linked in with carbon capture and storage technologies, which is another interesting technology but hasn't quite taken off yet. So I think I've probably gone on for long enough, and I'll maybe leave this slide here as to sort of show the work that is currently underway and is maybe feeding into this vision of what a future gas and electricity network could look like. So thanks very much.
Okay, I'll just kick off the Q&A session. Thanks a million, Rory, for an excellent presentation. That 6 countries signing up to the, what do you call it, by 2050 for the
green gas.
Green gas, yeah. We're Ireland one of them, and
Ireland is the 6th.
Yeah. And is that just an aspirational target, or is there any commitment behind that? I suppose, is there any government backing of that?
Well, there's government backing in this. The Commissioner for Energy Regulation has put in place the funding, or has allowed the funding for initiatives like the Gas Innovation Group. But in terms of more commitment, I don't actually know. I don't know how much gas is on the radar maybe of the policy making communities. I think a lot of the policy in Ireland has been focused on the electrical side. So I think it's probably incumbent on those of us working in the gas sector that we need to maybe get it further up the policy agenda.
Thanks, Rory. Bernie Stoll from Element Power. I just have 2 questions. One is, so the carbon dioxide emissions, from how does that compare with standard gas from the renewable natural gas? Mm-hmm. And secondly, the kind of efficiencies of the system in terms of, locating the anaerobic digester relative to transport for the substrate, Can you talk a little bit around that?
Well, those 2 questions I think are very much linked. So during the growing process for these biomass materials, they're obviously taking in carbon dioxide from the surroundings, and that same carbon is released when you burn the gas at the end of the day. Now, the differential, no biomass fuel is completely carbon neutral. People may claim that they are, but they are not, because there's processing, and a major contributor is transportation. When you're moving slurries, you're mostly moving water, and so from that point of view of efficiency, the closer you can get to the production site of that slurry, the better. So then, when you do have to move something to an end energy user, you're moving nice, energy dense natural gas as opposed to water. So, but then that fights against the argument of economies of scale. So it's that's why both in Cork and in Galway we're trying to get this optimization. We as people in universities, we like to think of it as like as a very mathematical optimization process, and in reality, obviously, it's not quite that elegant, I guess. That there's more realities in there, but there are carbon emissions, but they are to a large degree offset by the growth cycle of the feedstock.
Yeah, thank you.
I'm sorry, I can't put numbers on it.
Thanks. Joe Borza from Energy Elephant. It's a startup company. Just on fugitive emissions from the actual production of the biogas, is there? Have you modelled that into the process, or does it occur from a methane release perspective?
I'd have to defer from the anaerobic digestion side. I would have to defer to the people who've done the modelling, which is the research group in Cork. So I can't say for sure how much that's been modelled. I know on our gasification side, yes, we do model that. Fugitive emissions, the sort of the rules of thumb that people would use in modelling that is about 1%. Now, 1% of methane escaping that you produce, that can be a significant amount of global warming potential, just because of the very high global warming potential that methane has. So yeah, that's certainly included in our gasification modelling work. Yeah. Yes.
I'm Shane O'Sullivan from ESB, and I might stretch the boundaries of this presentation, but I'm just wondering about the suitability of the existing natural gas network for transporting hydrogen, however it may be produced. And I know, England is looking at this and for reuse of existing infrastructure in the future in a more carbon-friendly way. But yet, hydrogen is a very small molecule, so and can cause embrittlement in steel. So I'm just wondering, is it technically feasible to repurpose the existing gas grid to transport hydrogen?
There's been research done on the German gas grid where they have looked at putting in quantities up to about 5% by volume of hydrogen, and 5% by volume is a pretty significant quantity of energy on the grid coming from hydrogen. It's not something that's really being looked at here. I can't really say why it's not being looked at, but it is technically feasible in small quantities. I guess we're really more interested in producing a drop-in replacement as opposed to a blended fuel. It's not just the pipelines that would need to be adapted, or that may need to be adapted if hydrogen was introduced. Burners would need to be changed because hydrogen burns with a vastly different properties. My other hat when I'm not studying this is studying combustion properties, and hydrogen burns so much faster than methane that there would need to be a kind of a wholesale changing of gas turbine technologies at the ESB plants. So it is technically feasible, but it's not really being looked at in Ireland.
Hi, Rory. Barry McMullen from DCU. Thanks a million for the presentation. This is a slightly convoluted question, but I'd just be interested in your thoughts. I mean, you've obviously talked a lot about natural gas or synthetic natural gas in transport, partly because of all the other dirty stuff in diesel in particular, but also because of the carbon reductions. You've also mentioned the actual carbon reduction is not necessarily as big as one might expect, but it's non-trivial. So that's one way of thinking we can take a chunk of emissions out of transport. Okay, but the world and his wife wants to use bioenergy sources. So it's not just, the gas people who are looking at exploiting the bioenergy resource. I mean, aviation thinks it's going to save them completely, and everybody wants access. And you only have a very limited, as indeed you made clear there, just in terms of your own 2025 target, and that was assuming that this project was going to have exclusive access to the Irish bioenergy resource, in effect.
Well, to the residues.
Yeah, to the particular feedstocks. But you're also talking about taking all the marginal miscanthus potential. And that was a pretty big. I was at
UCD this afternoon, and they want to do something totally different with it.
Exactly. Now, at a global level, as you're probably aware, the IPCC scenarios, whether you believe them or not, but the ones that still say that we can actually continue somewhat the way we're going for another couple of decades and still respect the at least the 2 degree threshold, progressively involve assuming this thing called BECCS, bioenergy with carbon capture and storage, in the second half of the century. Now, the catch there is that you can only do BECCS if you burn your bioenergy resource in point plants, okay, because otherwise you can't capture the carbon dioxide. Whereas if you allocate your bioenergy resource for transport, for direct combustion and transport, you've no chance of capturing the carbon dioxide. So I'm wondering, in terms of the end point, is this biogas and transport a bridge to nowhere? Like, it's basically being presented as a bridge, an incremental thing. But if the end point is we can't actually do that because we need to reserve the bioenergy potential for use in BECCS, in point sources, surely we should be starting in that direction rather than detouring into converting our transport to go on gas first.
Yeah, that's that's a good observation. Yeah, I've seen the presentations you're talking about by the IEA, by the IPCC, with BECS, and as you say, it every single scenario has that in there. Now, does that mean all of the bioenergy potential needs to go through a CCS process? Maybe it does, maybe it doesn't. I don't know if all of it should. But what I do know is that when you use a bioresource, the fuel, the refined fuel that you get out of it at the end, has got those really energy-rich hydrogen-carbon bonds in it, and you've got a big energy density. And even though we're not going to get rid of all the emissions if we burn it in a transportation scenario, we're still going to enable driving practices to remain more or less unchanged. Ranges won't be too badly impacted. I guess what I'm saying is that I don't view the wholesale use of bioenergy purely for power generation as really playing to bioenergy strengths. From a carbon capture and storage point of view, it possibly works, but I think that having bioenergy solely generate electricity you're trying to beat wind and solar at their own game. They make electricity directly.
But it's dispatchable, so that's the big difference.
It is. Maybe there'll be ways around the dispatchability in the future with different types of energy storage, but I think that there's a key selling point with bioresources that have got this energy density that the electrical options just don't have yet. And so I do think that there is a role for it in the transportation application, but I completely take your point about the carbon capture and storage. Yeah.
My name is Ramachandran, call me Ram for short, okay? I'm from Engineers Island here. My question is, if you're going to inject the gas from biogas to the grid, the grid gas almost 95% methane on it?
Yes. Yeah.
But the biogas you get 60% maybe.
Mm-hmm. Yeah.
How are you going to make it to match with that?
So that's the that's the purpose of this funded project here. So the big step for anaerobic digestion to go onto the gas grid is this cleanup process. So we just can't put biogas directly onto the grid. The carbon dioxide does need to be removed, and the sulfur.
And the water. The water also.
And the water. Yes. Yeah. So no, we're absolutely not proposing to put raw biogas on the grid. Not even slightly upgraded. We're talking about bringing it almost to 100% methane, and that's what the funding for this particular project was about, was to fund the gas cleanup.
I was looking for some fund from somebody else, SAI.
Mm-hmm.
They told me to wait until January. What I was trying to do, you showed me something, that demonstration, showing the gas.
Yeah.
But what I was going to do, put a small generator
Mm-hmm.
and the gas cooker.
Yeah.
So I'll produce same gas I'll use for cooking
Yeah.
and use generator for producing electricity. I was going to do this in 1996. I didn't get enough fund for it.
Okay.
Because I was going to do for the farmers
Okay.
in the farm, with the cattle. But you already mentioned about it. In Ireland, the farmers don't keep the cattle in the shed in the summer.
Yes. Yes.
So I come with the idea, which is use solar panel and the biogas mixed together.
Mm-hmm.
So it will balance it out, the
Right.
production,
Yeah.
50-50.
Yeah. I guess that's maybe getting at the you're maybe pioneering on this, our integration of the renewables with the
That's right.
with the
So you can
biogas,
connect
yeah.
the grid also. Well, I don't know. The grid is good for you because you don't have to do the load balancing.
Yeah. Yeah.
But they pay 15 cents for before. Now they pay 9. They might pay nothing in the end. Well,
yeah.
if it's me giving you the money, I'll tell you, well, I'm doing the load balancing for you, so I won't pay you anything.
Yeah.
So this could happen.
I know that some of the research in Cork has looked at how far in advance you would need to add more slurry into a gas into an AD in order for it to get up to, say, to match the load that's required of the gas grid. So they're looking at predicting peaks in gas demand, and maybe 3 or 4 hours before that demand starting to load your slurry in and getting the bugs working. So I know that there's work in these predictive models in that area. So yeah, it's an interesting perspective. Yeah.
Thanks very much, Rory. Stephen Moran from Fingleton White. Just 2 quick questions for you. In relation to the HGVs, is there a requirement for dual fuel running on the vehicles, so say running a diesel at startup but then switch over, or is it 100% gas? And the second question is, do you know, are there any plans to incentivise CNG for private vehicles?
So I'll short circuit the second one and say I don't know. I don't know that. For the first question, my understanding is the funding is available for both dual fuel and CNG only. There are obviously pros and cons with both. So with the dual fuel, there's always going to be some redundancy on either one tank's not being fully used or the other. But then it can use a second fuel source. So yeah, they're both being investigated by Innovation Group funded projects. Yeah.
Thanks very much.
Rory, Donald Kissan, Gas Networks Ireland. Look, I'd like to congratulate you on a very good presentation. So I have a question and maybe a comment there on Barry's question.
Mm-hmm.
I said maybe that first really, and I'll predicate it by saying I'm a mechanical engineer. I'm not a chemical engineer or a chemist, but my understanding at a very simple level is that the advantage of biogas in the transport scenario is that if you get to a situation where you're using gas which if you like is near carbon zero, i.e. that the carbon that's emitted in the transport vehicles when you're driving around is absorbed, or 80 to 90% of it is absorbed by the process in making the biogas. That makes that section of transport near zero carbon. So that's my understanding.
Well, it's perfectly true, but you're missing the opportunity to go negative, which is what models say we have to do.
Yeah.
Near zero is good enough.
To go negative, though, I mean, you'd have to go negative in the power generation network. Is that possible?
You put on the CCS, you capture the carbon dioxide, you store it, and you've got net negative.
Yeah, I mean...
You can only do that with a point source. You can't do it with vehicles all over the place.
Yeah.
That's the key argument as to whether you allocate your bioenergy resource to transport where you've no chance of doing capture, so you've no chance of going negative, or in power generation where you can capture and you can go negative. But it's the one bioenergy resource, you can't do both.
And then you have to electrify transport and all the losses associated with that.
Actually, there's less than you might think.
Okay. Anyway, on to my question. On one of your slides there, Rory, you had a slide there around power to gas. So just a question on that. I mean, that's something that's been around for a while, and is in your view is the direction towards generating hydrogen or methanization of hydrogen, or where is that at, or would you maybe?
Well, yeah. So people have been talking about using hydrogen as an energy storage in its own right. That you would in peak production periods you'd electrolyze water, produce hydrogen, store that, and then use that to meet electricity demand. The efficiency of that is quite low, though. Of going to hydrogen and back to electricity, it's maybe 30 to 40% efficient what you get out related to what you put in. So something like a high efficiency battery or a pumped hydro would give you more efficiency, electric to electric. The nice thing, so that sort of says to me, well, keep that energy as chemical energy. Now, we've got no real widespread, easy way to get hydrogen around our economy, but we do have a way to get methane around the economy in the shape of the natural gas grid. So I sort of see it as it sort of ticks the efficiency box and ticks the practicality box to get the energy to the end user. So that's sort of why I would be more supportive, unless someone comes up with an extremely efficient hydrogen fuel cell. But that there's no reason to doubt why that wouldn't happen. At the moment, to me, going to methane seems to be a good option. Yeah.
Guys, we might just finish off with one more question, and then David Taylor's going from the Energy Institute going to wrap up.
Okay.
Sorry, thank you very much, Owen Flynn, student. At a previous lecture I was here, they talked about, I think the aim for 2050 was to do away, or to try and minimise the amount of fossil fuels used for transport and direct heating. And I'm just wondering, in your scenario there, do you envisage gas still be used for, say, the domestic heating purposes? Because I know at this previous talk, they talked about heat pumps coming in and the importance then of electricity, and the importance actually, if Ireland was to meet its commitments, that they actually take some control over the domestic heating aspect and the transport aspect. And as far as I know, I think the limit was 2050, if I'm memory right.
Yeah. So is the question, would I see a role for natural gas?
Well, I'm just wondering
heating?
what is, yes, in domestic, your current grid that's feeding most of the houses and certainly in mine, what it's doing is heating the place.
Yeah.
So I'm wondering, do you see that continuing on as that being the main objective of the gas?
Well,
function?
I would see that. Yeah, I would see that as being one of the objectives of the grid. So I just like to maybe separate the grid from the natural gas that's in it. So like the grid is there. What we're looking at doing is have the gas sourced from a renewable source. So that what flows through that grid in 2050 would ideally not be fossil fuel, or if it is fossil fuel, it's only a very small percentage fossil fuel. But the resource studies are the first step towards that. So, thank you.
Thank you very much. Well, Rory, just to congratulate you again, and perhaps to take the opportunity to say a few words around the topic. Just recent events, that we're all aware of. The primary driver in this case, Paris, 2015. But since then, we've had Brexit, and most recently, the election of Trump in the United States, and a certain level of skepticism developing over the pronouncements of learned institutes, academics and economists. So we're all in that space. And I suppose everyone in the room is aware that UTV have been running adverts for their program that's to issue, I think, or maybe issued last night, on the renewable heat incentive and the burning of money. And Primetime has jumped on the bandwagon, and they're going to be talking about renewable energy promotion in Ireland. Now, so in their different ways, those two channels have captured the public mood for having a go at, whatever's going on. So what does Paris signal? Paris signals it's game on. It's serious stuff, and it's not just playing around the edges. We're about to spend big money. And that big money is reflected in the 2024 targets that you see there. I mean, they're whopping, in terms of, and where it's going to come from is the question you're asking. So it's pretty clear from the very preliminary analysis that you presented to us that that level of ambition for 2050 is enormous and will have serious impacts. I think you did us a service by sketching out the electricity, transport and heat and reminding us that action on the heat and transport side were absolutely mandatory from the point of view of making any kind of meaningful additional contribution. And then you moved on to focus on the two key drivers, decarbonisation and infrastructure utilisation. Now, decarbonisation, you explained to us, has brought about its own consequences. The high level of ambition in the electricity sector has reduced the demand for gas, despite the natural pairing of the two. And that invites questions about what's the elephant in the room? What else could we do that's smart, that would resolve that decreasing use of gas infrastructure? The impact of that, of course, is that it feeds straight back into the price of gas, which feeds straight back into the possibility of growing the demand for gas, which needs to be done. So there's a difficult but temporary bind going on there. And in that sense, I think the work that you're doing, if you can prioritize out of this analysis and work quick wins, you know, like, for example, you've done with the CNG trucks, you know, a big move, air quality, cities, you know, etc. I was aghast, though, when you mentioned the filling time. I was expecting to hear, well, there won't be range anxiety here, but of course, if a slow fill, 5 hours, you know, that's a captive fleet.
That's a slow fill. There is the fast fill.
So it's got to be fast,
yeah,
you know, if it's going to go anywhere. The resource quantification and its spatial distribution, you know, is clearly evidence-based, you know, policy making, and absolutely essential stuff to do. If I can take the opportunity now just to make a plug for the Energy Institute, we've just launched an Ireland 2050 website, and if you go onto that website, you'll find a model of Ireland's energy system, which is at two levels, a 40 variable calculator, which I think professionals like you could use, and a simplified 14 version, policy lever version for the layperson. But they're both designed to feed into what you're doing here, encourage systems thinking, systems analysis. And I think one of the, and then just to kind of close the loop, that work where the regulator is funding the promotion of bio gas production, you know, in AD, I think that's very important, not for the quantity of gas that it's going to produce, but for ensuring that rural Ireland is familiar with the kind of stuff that you're talking about. And the list of communities that you mentioned there, you know, in passing, I think augurs very well for developing an informed consensus that will allow policymakers and the regulator to commit money to forward expenditure that will help us to and be able to assert, you know, that we're getting value for money for it and understanding along the way. So congratulations and thank you very much for your address this evening.
Thanks very much, David.
Okay, everyone, listen, thanks again, Rory. Just to wrap up, so our next lecture will be on Wednesday the 1st of February, and we'll be discussing biomass options for Money Point power station, so it's a very interesting topic. And with that, so I'll say for a moment again, thanks everyone for dialing in. Thank you, Rory.
Great. Thank you very much.